Hello, my name is Tyler Robinson. My major is instrumentation. By real world Ohm's law question, a TV has a resistance of 240 ohms and draws 0.5 amps of current. How many volts are needed to power it? If the current drops to 0.4 amps, what is the new voltage? Is that enough for the TV to still work? Connection to Ohm's law. You know the current and the resistance. Use Ohm's law to calculate the voltage needed to power the TV. When the current drops, you use the same formula to find voltage changes. Why this question matters: it helps power issues and understanding on why your TV might not work. Teaches how to ensure safe and efficient operations of electronics. It's a real-world example of how Ohm's law is used in everyday technology. So if your TV stops working, you probably need to use Ohm's law to figure out why it's not working. Developing the question. It adds complexity. What happens if the current changes due to a power supply issue? How does a voltage drop affect the TV's performance and safety? Which, if your TV has too much voltage, it could catch on fire and burn your house down. Use this understanding to troubleshoot power problems or design better electronics. Compared to other questions, this TV voltage question is more practical and slightly harder than basic Ohm's law problems because it involves real device behavior and changing current. Unlike complex circuit problems, it focuses on a single component. Table of values, resistance, current, and voltage. So when resistance is 240 ohms and current's 0.5 amps, the voltage is 120. When the resistance is 240 ohms and 0.4 amps, it's 96 volts. 300 ohms, 0.5 amps, and that would be 150 volts. When resistance is 300 ohms, 0.4 amps, it's 120 volts. Formulas and units. V equals I times R is the formula you would use to solve the problem. You have 240 ohms, 0.5 amps, and then 120 volts. Step-by-step solution. Given 240 ohms, current drops from 0.5 amps to 0.4 amps. Formula is V equals I times R, and then V1 equals 0.5 times 240 equals 120. V2 equals 0.4 times 240 equals 96. Verifying accuracy. The formula V equals I times R is the correct expression of Ohm's law, directly relating voltage, current, and resistance. Extra interesting information. Voltage drops like this can happen due to power surges, faulty wiring, or aging components, and can cause devices to flicker, reset, or even damage over time. Modern TVs include power regulation circuits to help maintain stable voltage despite fluctuations, protecting sensitive electronics. I did not know that at all. What surprised me is how easy our TVs can be messed up just by slight voltage change and can flicker or even have faulty wiring and can potentially catch on fire. The challenging part was trying to figure out the question. What I thought was easy was what surprised me, and then most valuable, probably knowing all the Ohm's law formulas. So if something, say, in my house or at like a job site or whatever with instrumentation, I can figure out the voltage or what's wrong with that certain thing, and I can fix it. And then my sources. Thank you for watching.
Hi, how you doing? My name is Walter Martinez, and this is our presentation on Ohm's law. My question on the Ohm's law was, a car headlights operates on a 12 voltage battery and has a resistance of 6 ohms. What is the current flowing through the headlight when it's turned on? So my connection with this, you know the voltage, which is 12, and you know the resistance, which is 6. You want to find the current using Ohm's law. You can calculate how much current flows through the headlights given the voltage and resistance. This helps in understanding how much electric charge is moving, which relates to brightness and safety of the current circuit. Why it matters is the safety. Knowing the current helps ensure that the wiring and components can handle electrical load without overheating, causing damage, and the efficiency helps in designing current that use power efficiency, preventing wasted energy and extending battery life. Developing the question would calculate the current flowing through the headlight when it's turned on. The battery voltage drops to 10 volts due to the low charge. What will be the new current be? Explain how this change in current might affect the brightness of the headlight, and if the wiring can safely handle up to 3 amps of current, is the system operating safely of a full battery voltage? Comparing to other questions, this question is unique because it combines practical electrical calculations with real-world implications, making it more than just a simple plug-and-chug problem. Here's what it sets it apart. Multiple variables in play. It doesn't just ask for a straightforward current calculation. It introduces a changing battery voltage, which reflects real-life scenarios like the battery drain. And this is my table of the scenario, voltage, resistance, and the effects. The formula for this is I equals voltage divided by resistance. So we know that the voltage is 12 and the resistance is 6. So by dividing 12 and 6, you will get 2. So the voltage will be 12 volts, resistance 6. 12 divided by 6 equals 2 amps, which is the current flow. Headlight is 2 amps. Verification using Ohm's law, I equals V divided by R, is appropriate here because the question involves a simple electrical circuit with known voltage and resistance. Substituting V with 12 volts and R and 6 correctly gives 2. Knowing the current flowing through the headlight helps ensure the electrical system is safe and efficient. It helps determine if the wiring and fuses can handle the current without overheating or damage. This fundamental understanding of Ohm's law is essential for anyone working with electrical circuits, automotive repair, and electronics in general. Extra information about this: Ohm's law wasn't accepted publicly. First, it took a while for it to be accepted. It took years before his law became fundamental to electrical engineering. It was a foundation of electronics. Ohm's law is the building block for understanding how almost all electrical devices work, from your phone to power grids. What surprised me is I didn't expect for Ohm's law to be in our everyday electricity, on how much it includes in our power, and it was fun calculating the amps. It was challenging for me to find the unique question for this type of assignment, and the easy part was explaining how it's used in everyday voltage. Once I understood the whole situation, and my most valuable lesson from this is realizing how we use Ohm's law for most electricity in our everyday power. And these would be our sources. Thank you.
My real world Ohm's law question: what is the resistance in a phone charger cable if it operates at 5 volts and supplies 2 amps of current? What happens to the resistance if the current drops to 1.5 amps while voltage stays constant? Connection to Ohm's law. Direct application of V equals IRV equals IRV equals IR. Used as real world devices, phone charger. Reinforces earlier definitions of voltage, current, resistance. Aligns with current principles discussed earlier. Why does question matter? The value of solving my question. Helps people understand how their devices work. Explains why chargers slow down or overheat. Builds problem-solving skills using Ohm's law. Makes abstract ideas tangible and practicable. Developing the question. Creating a useful and challenging question. Goal: involve a real device and multiple reasoning steps. Too simple. What's resistance when V equals 5V and L equals 2A? Too hard, involving alternating current or heat loss. Final version. Balance, difficulty, real world context. Comparing to other questions. How is my question unique? Textbooks. Basic plug and chug problem. My version adds real devices. Charger. A second part involving change in current requires deeper analysis and interruption. Tables of value shows inverse relationship between current and resistance. Help visualize how behavior changes in the circuit. Formulas and units. Ohm's law formula and unit breakdown. Formula V equals I times RV equals L. VVV voltage, volts. LLL equals current, amps. RRR equals resistance, ohms. Example values. Voltage 5V for the typical charger, current 0.5, 2.5 A. No constant needed, just consider consistent units. Step-by-step solution. Solving the problem in 2 steps. Step 1, R equals 5 / 2 equals 2.5. Step 2, if L equals 1.5 A, R equals 5, 1.5 equals 3.33. Explanation. Resistance increases as current decreases, could signal cable damage or inefficiency. Slower charging, possible heat loss. Issues. Is this solution correct and useful? Double checking. 2A, 2.5 equals 5V, 1.5A, 3.33 equals 5V. Relevance. Fits Ohm's law. Explain real issues with cables and chargers. Extra interesting info. Fun facts about George Ohm. His work was rejected during his lifetime. Ohm published his law in 1827. Later contribution to acoustics and telegraphy. Now a standard unit bears his name, Ohm. What surprised me? Didn't expect such small changes in current to impact resistance so much. Chargers don't always list resistance, have to calculate it. Learn more about how important cable quality is. Reflection of the process. The hardest was creating a unique, useful question. Easiest was applying Ohm's law to solve. Most valuable, realizing how theory applies to devices uses daily. Learn to connect math to real-world outcomes. Sources and visuals. Conceptual Physics by Paul Heward. Khan Academy, Ohm's Law, Rapid Tables, Ohm's Law Calculator. Image by phone charger or any phone charger.